Hello, programmers. I'm Nitesh here. It's currently 1:30 a.m. and I've been trying to film this video since 1 hour. And every time I film it and complete it, there is some problem. Like I completed a video like 5 minutes ago, and it had a microphone problem. Whatever I said, I don't know what happened, but I couldn't hear it back. So welcome to my eighth episode. Some people wouldn't know, but this is my eighth episode. I have a running playlist on random things that I like to do, which is programming and robotics. I just post a bunch of these videos. So today I kind of want to post about something we did in our Fed's robotics meeting. Uh, so we went from normal understandable trig to trying to comprehend vectors, and sometimes for some reason I even started talking about vectors, no, matrices. So let me just like I want this video to be like a summary of what happened so that we are all in a good shape. This video is for both who are doing subsystem A, subsystem B, like all of them. So hopefully you guys are actually seeing this video. It doesn't matter. This is optional, but hopefully you guys are seeing this because I did put a lot of effort into making this video. Way too much than I really wanted to admit. Okay, let me show you the third vector simulator that I came up with. Okay. Um, okay, let me see everything. Yep, that's good. So I want to like show you a bit more on what this is about. Okay, so this is our turret center, right? This guy is a turret center, and your blue guy is your limelight. And this area, the shaded region, determines the range, the field of what the limelight can see. Okay, all this limelight is limelight 3, which has uh 31.3 degrees of freedom in each dimension. It sees in two dimensions. One is your left and one is your right. Technically, it's not dimensions, but whatever. Okay, you get the point. And your orange circle is basically where your April tag is located relative to the turret. Now, does that matter in real life scenario? Not really. I just want to have a way for you to like check it, right? And third yaw is basically uh this is 0 degrees and this is going to be 90 to 70 or no 180 to 70 0. Okay, so that's the actual degree that our turret is right now facing. Right now it's 0, perfect, right? And I also want to later go over the step-by-step explanation, and I would also want to show a little bit on the graphing toolkit. Okay, cool. Let's start with what our problem is about because I know I know most people know exactly what our problem is, but I do want to go over it just to make sure, right? So this is our amazing robot made by Sachit, um, and Sachit or Cat team, right? And that team made it, not just Sachit. But I want to show you a couple of these things. Before, the limelight was right in the center of your arm, which is this guy, the straight guy, which was very easy, right? We just have to like move whatever degree the limelight wants us to go, and that was kind of it. But what happened is we moved the limelight 2 point. Let me try it. Okay, so we went exactly. How do I see it? Come on, man. Come on. So you like that, and then you like that. Okay, so we went exactly. Okay, whatever. So I know this. It's 2.5 inches to your left. And that changes your whole spectrum. This is now different. Okay, this is a little challenging for us. This is what we all needed, right? We all need a little bit more challenge to our robot challenge. Um, so we came up with a variety of ideas, starting with like your normal trick function to matrices to right now vectors. Okay, vectors are pretty uniquely interesting topic. It's not really that hard to like perceive it, but just looking at it makes your brain a little fuzzy. I hope in with this video I could like clear up a little bit, maybe. And obviously, while we program this, we will get through this. We have to get through this, so we will do it anyways. Um, so now let me just run my simulators. Okay. So right now I am out of the range of what my lamina can see. So it tells me no, which means it can't see the target. And obviously your dart is still 0 degrees. And aim error is basically uh this data. Control one, this data. Okay. Would Limelight give you aim error exactly? Not really, because it's not in the range, so it wouldn't give it to you. But since this is simulation, I could get the error value. And camera TX, this is what the Limelight would give me if it's in the range, but right now it's not in the range. Remember, if it's 31.3 degrees, it can see it. Anything more than that, it cannot see it. Okay. So let me just start the simulations. So right now, my Apple tag is here. Now I want to simulate the turret moving left and right. So let me just rotate left. So that's how it rotates left. And let me just rotate right. Right. Look at the turret. Yeah, it should go exactly as we planned. And now let me go to your right side. I'm not in the range. Okay, now I'm in the range. Let me pause it here. So right now, POV, yes. And my turret angle is 13 degrees. My aim error is 23.5 degrees. That's very important. That's exactly how much degrees we had to turn to make sure that, oh my God, that our arm reaches to the April tag. That's exactly how much degrees we had to turn, right? Camera TX is what the camera, like our lamplight, would give us. Okay. So that's kind of basically the simulation. Obviously, if you ever want to, if you want to play with the simulator, I can probably host this up for a couple of days, and you guys can play with this. Obviously, I can do that. Just let me know if you need it. Um, okay. Now let's go to the math explanations. So obviously, we want to explain this. And our mission is to compute the turret aim angle, the angle of the vector from the turret center straight to the April tag target. Um, so what it's basically telling you is, from here to here. Okay. All right. So we call this goal. We can call this goal. We can just give it a variable. So in other words, I can basically use the graphing toolkit. So this is my center. Okay, this is my turret center, and my April or my camera is like over here relative to origin, which is our central target. So let me just the word relative is very important. I will tell you why exactly. So right here, 2.5 and 3.7. I can't really have this red in between, so I'm just gonna do it here. And let's imagine my April tag is like here. I'm gonna change the color though. I don't like the color. Let me change to purple. Yeah, that sounds about right. And let me make a vector out of it. Oh my God. Vector. Okay. And then, and this is also a vector. So let me just make a green vector out of it. Vector. Okay. So these are our vectors. This is the offset between our turret and our limelight. And this is what we get from a limelight. So let me just make a um, component, okay? This is your T TX, okay? And this would be your TY. Both are given by limelight. So you really don't need to like know anything special. This is TA. This is also given by limelight. You don't even need these things. You can just calculate it just from the limelight. Okay. Uh, I, I just made a mess with this, but it's fine. It's fine. Anything for science, you know. Okay. So in engineering, we really don't want to think this. We want to think from here to here straight away. So that would be our golden line. Right. Let me give you a golden line. Don't worry. Give you a golden line. Make vectors. So this is what we are interested in. So in the next couple of slides, we are going to look at it. Okay, that's your goal, V goal. Remember, you have three vectors mainly in the subject. You have your V camera, that's what your camera is going to give you. Your offset, that's from your turret center to your limelight. That's your offset, right? Negative 2.5 and 3.72 are real offsets from the robot. It might be changed because Seitet is changing a couple of things in the limelight, so it might be changed. And your B goal is just you add these two together. So look at this. You first have your offset, and if you add this vector, you basically get your yellow line. It's so simple, right? This is called transformations. Okay, this is your linear transformation model. This is linear. These are non-dynamic. Okay, this is linear because it has lines. It has straight lines. It's not curved unless it is curved. Then it's not linear. But right now, just for us, this is not curved. We are not going to go into curved transformation. This is linear. Just remember that. Um, okay, we know that's a target, that's your turret, that's your goal. Next is we had to set up some coordinate frames. Obviously, you have your turret, which is 0, 0, and then your camera, which is relative to your turret. The reason we keep turret 0, 0 is every additional frame you create for turret or the way you represent that in your graph, your math would go infinitely complex. So if you want your maths to stay friendly, you gotta add in the relativeness. So if I said turret as my relative origin, then my camera is gonna be relative to the turret. So whatever distance it's from my turret's central angle. Okay. So just a refresher, if you don't know, 2.5, 3.72. Just making sure you know that. And the turret's pivot is what we call as a true field. That's what we are looking for, right? And your C frame is just what the vision system reports, like your limelight camera reports. Okay. Now we'll look at all these vectors. We'll look at these vectors. These are called static offset vectors. The reason we call it static is because these are basically constants. This offset would never change no matter what. No matter where you go, that specific offset would never change. It would be 2.5, 3.72. I want you to remember that. Okay, that's really important. If it does change, then I'm sorry. I'm sorry. You gotta do your math. Okay. And your vision vector, this is your dynamic vector. This is changed based on the distance you're from the airport type, the angle you're from the airport type, and quite a bunch of stuff. You can see that with your let me go to say Nigeria. Yeah, you can see that the red line change, the blue line changes, red and blue line changes based on where I go, right? Just want to remember that. And next slide, please. Okay, so we can just set up this equation. So V goal is equal to V offset plus V cam. V goal is equal to V offset plus V cam. It goes to the same line, right? It's just relativeness. So we go from turret to camera. That's your vector number one. Plus camera to target, vector number two. You get turret to target. Simple, right? Um, and boom, here. Bonus, this is your step 8, which is your last step, which is just to get your amazing degree so that you can just move there without having things showing up. So obviously dx, dy are the things that Limelight would give to you based on where the target is in its field of view, right? Your camera dx is just arctangent to and then your x and your y component. What does arctangent do, you say? Well, remember, tangent is tangent of theta is just opposite divided by adjacent, and if you want to find theta, you gotta do tan inverse of opposite and adjacent to get your theta, right? This is basically the same thing, but a tan 2 is basically a combinations of different functions, right? This is a poly function, okay? So a tan 2 looks at quite a different stuff. If x is greater than 0, then it just takes a normal arctangent. If x is smaller than 0 and y is smaller than or equal to 0, then it does the same arctangent function, which is just tan inverse. It just adds a pi. And it based on what x and y is, it changes the way it's processing that so that you wouldn't get undefined in your 90 positive negative 90 or positive negative 270. And then if x is 0 and y is 0, obviously you get undefined because you don't have a direction there. You're a single point, right? That's what that is about. And once you get that, third angle is easy. Third angle is really easy. So your third angle is basically tan inverse of your y component divided by your x component. You get your degree, you just go to that degree. Simple enough. Okay. That's kind of what I want to talk about at least today. Um, let me know if you want any of these resources. I always have these things handy. I just wouldn't want to give this if you don't need it. So let me know if you need it. I can give this to you, no problem. Thank you for watching. I hope you learned something new. Uh, yeah, thank you. And it's basically 2 a.m. I should probably go sleep. All right, see you guys.